Section 8.3 is about the inverse of a square matrix. So this section further develops the algebra of matrices, what we kind of did last unit with, or last section with addition and multiplication. If matrices can be added, subtracted, or even multiplied, then other ideas from the real number system, like we've been doing for much of our mathematical careers, must also carry over as well. For example, inverses. Inverses we've used for functions, but they're also going to be useful for matrices. So let A be an n by n matrix. It's a square matrix where it has the same number of the same rows. And let I sub n be the n by n identity matrix. I'm going to pause right there because we have not defined an identity matrix, even though we've technically used them. Let me give you an example of an identity matrix. So if I do an I sub 2, that means it's going to be a 2 by 2 matrix. And the 2 by 2 identity matrix looks like this. 1, 0, 0, 1. Kind of looks like the left side of those systems of equations matrices that we made earlier. If we do an I sub 3, that'd be a 3 by 3 identity matrix. And that would look like 1, 0, 0, 0, 1, 0, and 0, 0, 1. So again, pretty familiar, pretty similar to what we were using when we were solving systems of equations. Anyways, back to this definition here. It says, if there exists a matrix A or A inverse, which I'm getting ahead of myself, it's because it's going to say, how do you read that later? A inverse, such that A times A inverse equals the identity matrix, which is also equal to A inverse times A. Remember, we said in the previous section that matrix multiplication is not necessarily commutative, but it is when you're using a matrix and its inverse. Again, the rest of it's just kind of saying what I've said out loud. A inverse is called the inverse of A. The symbol A with the -1 up in the exponent, we read as A inverse. So, example 1 here, we're asked to show that matrix B is the inverse of A, and A is -1, 2, -1, 1, and B is 1, -2, 1, -1. So, we got to start off by doing A times B. Now, matrix A is, again, -1, 2, -1, 1. And we're going to multiply that by matrix B, which was 1, -2, 1, -1. So if they're truly inverses of each other, we should end up with a 2 by 2 matrix that looks like this matrix up here. Should end up as the identity matrix. So going through this piece by piece, and I'm going to kind of just do what we did at the end of last section. We're going to do this first row, there we go, first row here times the first column here. So we have -1, sorry, air server is being a little slow right now. There we go. -1 times this +1 over here. Okay, sorry. -1 times this +1 over here, giving us a total of -1. And then we're going to add it with this 2 times this one, so it's going to be -1 plus 2. So that's going to be, again, our first row multiplied by the first column. Now we're going to do the first row multiplied by this second column. So it's going to be -1 times -2, which gives us +2, plus 2 times -1, in other words, -2. We'll clean that up in a second. For the second row, we're going to do the same thing. So we can do -1 times, and we're doing it times this column. So -1 times this 1 gives us -1, plus this 1 times this 1, so +1. Now we're going to move on to the second row here times this second column here. So we have -1 times -2, giving us +2. Then we have this 1 times this -1, giving us -1 or -1. Cleaning this up a little bit, we got -1 plus 2, that gives us +1. Oops, sorry, that's not a writing tool. +1. Then we have 2 minus 2, which gives us 0. Moving on to the second row, -1 plus 1 is also 0. And finally, 2 to -1 gives us 1. So it ends up with that identity matrix. Ta-da! Now we do need to check the other direction, so we're going to check that as well. So we're going to do B times A. So remember, matrix multiplication, not necessarily commutative. You might get different answers if you move them around. So we're going to now start with matrix B, which was 1, -2, 1, -1. There we go, caught up with me. And then we're going to multiply that by matrix A, which was -1, negative 1, I was looking ahead, 2, negative 1, and 1. And now we're going to do the same thing. We're going to multiply these two matrices, again, starting off with this first row here, times this first column here. 1 times negative 1 gives us, that's not a writing tool, gives us negative 1. And then we're going to do this negative 2 times this negative 1, which gives us positive 2. Now we're going to move into that first row times the second column. So 1 times 2 gives us 2. And then we're going to take this negative 2, multiply it by this 1, and gives us negative 2. Now move on to the second row, 1. So we're going to multiply this row by this column. 1 times negative 1 gives us negative 1. This negative 1 times this negative 1 gives us positive 1. And so we're done with that column now. Now we're going to do this row times this column. So 1 times 2 is 2. And negative 1 times 1 gives us minus 1. Cleaning this up a little bit, looking at that first row, first column sum, we got negative 1 plus 2 gives us 1. The first row, second column, 2 minus 2 gives us 0. Moving on to the second row, negative 1 plus 1 gives us 0. And finally, 2 minus 1 gives us 1. Hey, look, it's the identity matrix again. They are, in fact, inverses of each other.